I'm trying to record this presentation so that later you can. Okay. So as discussed, yes. So we're going to cover these concepts. What is bias and variance, overfitting and underfitting in ML models, and what exactly are the learning curves. So in order to learn this, what we will do is instead of directly learning these concepts in a theoretical way, what we will do is we will learn it with the help of a simple machine learning model used for linear regression. So let me quickly explain you what is linear regression. Most of you already know that you have been doing it in various mathematics. You have been using it since 8th standard, 9th standard. What exactly is linear regression? But let me explain you in a layman's fashion what exactly is a linear regression. So to understand what exactly the linear regression, uh, okay. Okay, so I have chat window open. Okay, so do you see this figure? The figure on right hand side. So now remember here on this figure on X label I have a value for X1 variable, and on Y axis I have a value for variable Y, right? So these are some of the points plotted for x1, and this was the corresponding value of y when x1's value was on this. So for some x1 value, the corresponding y value has been plotted. My question is, so here my question is, uh, where's the color? Okay, so my question is, what will be the value at this point? So the cross which I have put, what will be the value at this point? Can you tell me? The intersection of this cross where I have kept, what will be the value here? Can you just put it in chat window? What will be the value at this point? So those are the blue dotted lines. What I am asking is, what will be the value for of y when x1 is, okay, let me make it even more simple. So when I say here the x1 value is what it is, let's say point 0.72. So when x1 is 0.72, what will be the value of y? I'm Let us forget about accuracy. You can tell it in a rough range as well. Yeah, what Lalit is saying is it should be for x is equal to 0.7, y should be 80. Okay, approx fine. Any other answer? Okay, so I can see 75, 80, 0.7, 80. So, yeah, so you might, some are saying 70.89. Okay, so these are one. So, how you were able to guess? Remember, the question is whether you are able to get the right answer. That was not the intention. My question was, how come you were in a position to guess value for this? Because you only had this data. What you had? You only had this data. How come you guess the value for this value? Why did you guess? Why did you guess that the value of this would be 80? Why didn't you guess the value of this could be somewhere here? It could be right. Technically, the value of y could be somewhere here as well. It could be here, or it could be somewhere here, or it could be here as well. But why did you guess this as a more correct point? Why did you guess this value as a more correct point? There should be something, right? There should be some base based on which you have selected that the likelihood of y being 80 for x is equal to x1 is equal to 0.7, you have guessed it. What was the main reason for you to guess the value of y to be 80? What was the main reason? Why did you guess that y should be 80 only? Why I can see a lot of students answer 75, 80, 80, 89. But no one has said, sir, y value will be 60, or no one has said y value will be 90. He has always predicted in this range. What was the reason? Why our minds tried to guess the value of this at in this range? Why did it go to the other point and other? The reason for that is that whatever you have done something called as linear regression. Your minds have done a linear regression. So when I said that these are the data points, your mind has tried to learn. It did some training assignments on this data set. So when it did this training assignments on this data set, it has predicted that the points where these values are increasing, they are increasing in this linear fashion. So you have looked at this data sample. By looking at overall sample, you guess that whatever the value is there, that value should be in this band itself. That's what you have guessed, in this band, right? That's what you have guessed. And when I say to guess a value something beyond the data samples, what you did is called as linear regression. So trying to guess a linear equation for these data points. Once you guess that linear equation, in our words, the linear equation was the linear pattern you have found. Our minds have found this linear pattern. And whenever I have asked the values for future predicted values, you just went on this linear growth and you just predicted the value will be 80. Understood? So this is called a linear regression. Our minds did this linear regression. And the same linear regression can also be done by a machine learning program as well. I hope you're getting what exactly I'm trying to say that. Fine? Have you understood what I'm trying to say? Now I think you should be fine. Like when I say machine learning, what exactly machine learning you're doing? You're learning from the data samples and then you're trying to predict a pattern, and based on that pattern you have predicted the value for y. And when you do it for linearly growing or linearly increasing order of data samples, we call it a linear regression. Fine. So now I hope you understood this concept, right? Okay. So did you get the point? Have you understood that? What exactly I'm trying to say, whether it's what I was trying to teach here? It's very important that you understand this ability of our minds to predict point in future based on looking at the samples. So now the problem is that as a humans you could predict. Now what I want an algorithm, or I want a program which does this guesswork for you. By looking at these points, it has to guess this value. Whatever you are building, whatever algorithm you're writing, that is, I would personally call it as hello world of machine learning. Here is where you introduce machine learning to the audience. So here you will learn how to write an intelligent program which does the guesswork, what our minds did here, right? So before we write that program, we need to understand these concepts: bias, variance, overfitting, underfitting, and learning curves. So our programs depend on these parameters. Let me explain you these parameters. First, I'll explain you what is bias and variance. Then we will move to the concept of overfitting and underfitting. And then we will move, in the end, we will move to the concept of learning curves. Let me tell you what exactly is a bias and variance first. See, now assume that you have written a machine learning program. You already have a machine learning model, you have written algorithm and all that. Now, for that algorithm, for example, I am asking it to predict value for y is equal to 0.8. Let us suppose for this value x1 is equal to 0.8, I am asking my ML model to predict a value. Now, assume that technically the right answer for ml equal to 0.8 is say, okay, the value for that is for point 0.8, let's say the point 0.8, the value is this is the value I am expecting. So what's the value I am expecting? This is the correct value. What I am expecting, the correct value is 80 for that. This is the correct value. But my ML model, but my machine learning model, what it is trying to guess. Let me change the color and use some. Okay. But what my ML model has done, it has guessed this value. Okay. I'll make it as red. Right. So now when my machine learning model has guessed this value, let us suppose it might have guessed it as 85. So it has guessed the value 85. Now, what is the difference you see here? What is the difference you see here? What it is? It's, see, the real expected value is 80, but your ML model, which learned some pattern on this data points, it has guessed a value 85 for x1 is equal to 0.8. The difference which you see here, this is called as error margin. So this is something related to the accuracy of your model. Your model was not able to accurately predict the value between the expected value 80 and the predicted value. This difference is error 1. Now what happens is it has predicted 85, this difference is error. Now if I generalize this, for example, for 0.1, 0.82 and 83, now if I say this was your expected line, like your points, this was your expected line of points, right? This was your expected line of right points. But what your ML model has done, your ML model has predicted on this line. For example, it started predicting on these points. Okay. Okay, so now you should see that the black colored line is your expected and right values. But what your machine learning is predicting, see, so for 0.6 is predicted 1 dot, 2 dot, 3 dot. So all the values your machine learning is predicting, they are on this red line equation. So here, if I ask you, is my ML model, is it so what I'm trying to say is, for question, if I want to frame a question here, do you say that my ML model has guessed the pattern? Did it guess the pattern? If I say the red line is what my ML model is predicting on this red line, if I ask you a question, do you think my ML model which we have developed, did it guess the pattern in these points? Yes or no? What do you think? Did it guess the pattern? Yeah, Lalit has replied, yes, it has guessed the pattern, but not expected one. See, it has guessed the pattern that my all future, it has guessed that linear pattern of linearly growing in a some with some slope value, right? It has guessed the pattern, but is it accurate to our expectations? No. So now what we do is, yes, it has guessed the pattern, but what is the difference you see here? That this difference is not letting my machine learning model to be accurate with actual predictions. So this difference between the expected values and the predicted values, this difference is called as bias. What I call it as, this expected difference is now called as bias, right? So let me tell you, so this is called as bias. Okay, understood this? So now you know what is bias. Now let me say let me also introduce you the concept of variance. Now, this is guessed your pattern, uh, and for a short one, let me change the color. Okay, now I'll use this green line. Okay, so see, this red was for bias. Now, for zero point 0.6, let us suppose I have 0 0.6, 0 0.7, 0 0.8, and all this other lines. So for this, uh, let us suppose this is my machine learning curve. Okay, somewhat that's how my uh, the machine learning has guessed this line. Assume that my machine learning, instead of this red line, it has guessed this green line, right? So when it has guessed this green line for 0.6, for zero point 0.6, you can see here it has guessed a wrong value, but for zero point 0.8 it has guessed the right value. See, the green line actually falls on zero point 0.8 prediction values, but for some value here, it has once again deviated from the expected value here at this point. But for zero point 0.1, so somewhere here, it is once again on the expected point. So your machine learning has predicted the pattern, the growing pattern of that, but the outcome of machine learning model, it varies for value to value. So it deviates from value to value. So there is no consistent predictions by ML model, but the value varies from the expected values with very high differences. Sometimes it is correct, the difference is here. Another, there is no difference. Once again, it is difference here. There is no difference here. So this behavior is called as variance. What I call it as? I call it as variance. So a machine learning model has a high variance. It means that for some data point it predicts right answer, but for some other point it predicts a very far and vague answer. So this variance in its outcome is always present in the model. So these are the two concepts the ML models always suffer: bias and variance. So now, if I ask you, say I'm asking something beyond what I thought. I'm just trying to ask a question based on which I can gauge your understanding. So if I ask you a question right now, what a ML model is expected to have? A ML model is expected to have high bias, high variance, low bias, low variance, or it requires high bias, low variance, or high variance and low bias. What is a perfect ML model? Will it have high bias and variance, or will it have a low variance and low bias? Yeah, as Lalit has said, see, a perfect ML model needs to have low bias and low variance. And I can see Vanchika has asked a question. What she is asking is, does error margin mean bias? No. See, error margin is for one single data point. When I say error margin, I am making it for one single point. When I do, or when I calculate error margin for all the data points, the general behavior of error margin is what I relate with either bias or variance. Error margin is for one single point prediction. I'll take error margin for 100 points, and then I'll try to guess a behavior for how my error is behaving. Is error increasing as in when I take more points, or error decreasing as in when I take more points? So the behavior of error margin is what I represent in the terms bias or variance. Clear? So now I'll show you a small figure. Let me take this. Just a minute. Okay. So when I have this, So do you see this image? Okay. So this is what we call it as bias and variance plotted in one. Imagine this is I hope you know archery, right? So an archer is trying to hit the red spot, the bullseye, right? So here you can see that see here at this point, let us first talk about this figure. First, let us talk about high bias. Here, what is your opinion? Is Archer accurate? See, here, do you doubt the capability of Archer? The Archer is able to pinpoint on a specific point. The skills of Archer is good, but he is always deviating from the actual expected values, right? This is called as high bias. What it is? This is called as high bias. So he has a good precision. He has a good precision and a good skill, but he is not accurate. I hope you're getting my point. He has a good precision. He is learning well. He has a good precision. He understood the skills of archery, or he understood the art of learning from the data samples, but he is not accurate. This is called as high bias. Fine. And now here, if you look here, so if you look at this high variance here, do you say he is accurate? No, he is not accurate. Is he precise? Did he learn the skill of archery properly? Did he learn from the data samples properly? No. High variance means every time he deviates. Here is one prediction, here is another prediction, here is another prediction, and here is another prediction. So this is called as high variance. But he has a low bias. He is varying from the target. So he is on the target, he is able to aim the target, but he is deviating every time. This is called as high variance. So every time you predict, it changes. So the difference between each predicted values is very high here in this case. Consider the difference between this point to this point, this point to this point. This is called a high variance. And now, when you look at this figure here, just a minute, just please give me a minute. So when you look at this figure, what do you see here? Here you see a very high variance. He is varying. Also, he is away from the target. So this is an example of high bias and high variance. And this is what we ideally expect. What we expect here, we don't want him to be very deviating from the actual target. We want him to be precise, and we don't want him to vary. This is called as low bias and high low variance. This is expected model. So for every ML model, this is ideally what we expect. This is number one preference. So I hope now the concept of bias and variance should be clear to your mind. Is it clear? Let me know if you have understood the concept of variance and bias. Okay, and others? Okay. Okay. So yes, it's very important to understand variance and bias, right? Okay. Now, let me quickly explain you the other remaining terms. Remember, we will be seeing it in tomorrow's lecture, but I'll tell you the bias and variance, whatever you are right now looking at, these are something which happen after ML model has learned from the data samples, right? So as per our lecture, what we understood that we want low bias and low variance. So what should I do during machine learning or during machine learning training process so that I always get less bias and less variance? So that concept of how to build a machine learning model which will give you less bias and variance is done by learning the remaining two concepts, which is overfitting, underfitting, and learning curves. So what exactly is overfitting? What exactly is underfitting? And what are learning curves? We will see in tomorrow's lecture. In short, see, this is the behavior shown during training. These are the behavior which are shown during training. And if I can control these two parameters, overfitting and underfitting, if I can control them, then I can directly control the bias and variance as well. So during training, I have some indications whether my model is overfitting or underfitting. And if I can control those parameters during training itself, I can reduce them. And if I can reduce this too, I can indirectly, I can reduce the bias and variance of ML models. So how do I know that my ML is going into overfitting direction or underfitting directions? By looking at the learning curves. So during machine learning training process, if I look at this learning curves, it gives me indication whether my ML model is overfitting or underfitting. If I say my ML model is overfitting, it will most likely result in variance. If my model is underfitting, it could most likely result into bias. So that's the standard behavior. So in tomorrow's lecture, we will learn what is overfitting, what is underfitting, how to find out if my models are overfitting or underfitting. And if I identify that my ML model during training is overfitting, how to reduce that. These concepts we will learn in a subsequent lectures. And once we learn this overfitting, underfitting, and learning curves, what we will do is we will now write a Python program which will do this guesswork of this pattern guessing. So we will implement linear regression using scikit, or we will write our own Python program as well. That time it would be very clear how exactly machine learning works. Okay. So any quick questions? So if no questions, then I think you can mark your attendance, and you should be free to call off the session. And if you have any questions, please discuss in Telegram group. I'll try to answer your doubts there itself.